G'day. You've just started watching the 11th video in a particular series of Jim Coroneos' 100 integrals, in which I'm solving one integral per video. And this is his 11th challenge to us. You can see that we have a quadratic equation in the denominator, a linear equation in the numerator, and therefore it lends itself instantly to a logarithmic structure. But we have a complication. The quadratic's been factorised, which gives us a strong hint that maybe we should go the way of using partial fractions. Now, normally when we work on partial fractions, we would write on the side of the page a over x plus 4 plus b over x plus 2, unite those two fractions into one and get simultaneous equations in a and b so that we get x as the numerator. I'm going to try and speed that process up a little because I do notice one or two nice features about this. First of all, I notice that 4 is exactly twice 2, and that means that one of my numerators is probably going to be 2, or at least it'll be twice the other numerator. And also, if I have two x's and one x, that's a good way of getting x. So I'm going to have to double that, which means the numerator of that is going to be 2, and that will give me the 2x. So I'm going to put this first and put this second. So this numerator is twice as big as that one, and I think you can see that this will give us 4 and that will give us 4, and we need to subtract because there's no constant here. Let's just check this out. If we multiplied the top and bottom of this by x plus 2, now I'm not going to write it here, please forgive me, oh, I can't help myself. And this one here, I'd multiply top and bottom by x plus 4. On the bottom we have exactly this expression, but on the top we've got 2x minus 1x, that's it, exactly the x we want, and we have 2 2's are 4 minus 1's 4 is 4, gets rid of the constants. This is exactly what we want, so we've just saved ourselves quite some effort getting those partial fractions set up. So that's what we're going to integrate. Now I'm going to split it into two so that we can look at it more closely. The first integral is this one, and I'm going to move the 2 out the front. Well, you may ask, but I guess you've probably already worked out why. And this one, of course, I'm just going to write as the integral of 1 over x plus 2. Why did I do that? Because the derivative of x plus 2 is 1, and the derivative of x plus 4 is 1. I didn't actually want the 2 there, so we just moved it outside the integral. And this structure now is exactly what we need to give us a logarithmic expression. So our answer is 2 log x plus 4. Now, properly speaking, because x plus 4 could take on negative values, we use the absolute value sign, minus the logarithm of x plus 2 plus c. And there we may stop, but we know some logarithmic rules which will help us to resolve this into a much simpler expression, or at least simplify it. This 2 at the front could be moved inside as a power. And since we're subtracting logarithms, it means we're dividing the numbers. So I'm going to divide by x plus 2. And again, because x plus 2 can take negative values, I'm going to use the absolute value sign. And there's our solution, nice and neat. It just required us to see that Jim Coroneos had actually done us a favour in presenting this to us in factorised form, ready to go to use partial fractions. If you've enjoyed it, please leave a comment. I'd love your feedback. Click the like button, and Please subscribe to find out about the future videos in this list, plus others. And I thank you very much for watching.